Hello everybody. Now in our next lecture of physics, we are going to start electric field lines. As a students, we have already discussed about the electric field, and now at here we are discussing about the electric field lines. As electric field is a vector quantity and its formula is E is equal to F upon Q naught. Q naught is the test charge. It means that force per unit test charge describe the electric field, that is the vector quantity, and force is also the vector quantity. Now another concept also comes, which is electric field lines. So what is electric field lines? It is an imaginary concept introduced by Michael Faraday. The electric field lines are the imaginary lines. Actually, these are the imaginary lines which we see. First of all, field lines we cannot see. We see the effect. For example, whenever we place a positive or negative charge in the presence of some invisible property, and if this positive or negative charge will displace from its position, then there must be some electric force, there must be some electric field, and it is only due to the presence of electric field lines. So here, from that invisible property, the concept comes about the electric field lines. So electric field lines are the imaginary lines and introduced by Michael Faraday. Field lines are imaginary, but the electric field is real. So electric field lines is an imaginary line or curve drawn through a region of space so that the tangent to it at any point in the direction of electric field vector at that point. It means let us suppose here is the positive charge. Electric field lines, first of all, is the property always start from positive and ends at negative. Electric field line will continue up to infinity if the negative charge will not be closer to the positive charge. So it will start from positive and ends at negative. We can also draw electric field lines in this direction because electric field lines are continuous field lines. These are not closed lines, these are continuous. Actually, if the field line go from positive to negative and returns back to negative, that is called the closed. But if only it starts from positive and ends at negative, it is known as only the continuous line, not the closed. So these are the imaginary lines. So electric field lines always start from positive and ends at negative. Now, what is the tangent? Let us suppose this is the electric field line and I want to know the direction of electric field line at any point. This is the point P, this is the point Q. So if I draw the tangent to this point P on this curve, then EP denotes the electric field line at the point P, and EQ denotes the tangent on point Q denotes the electric field line at Q. So the tangent at any point on the electric field line or curve represent the direction of electric field line at that point. So electric field line are the curve, are the smooth lines, continuous lines which start from positive and ends at negative. The number of electric field lines linked with the unit area of cross section is proportional to electric field. It means that whenever the number of field lines are greater, electric field strength is greater. Whenever the number of field lines is less, electric field is weak. The electric field lines for a positive charge. Let us suppose in space positive charge is there. So electric field line always perpendicularly outward from that charge in radially outward direction. And these field lines will move up to negative charge or up to infinity. What do you mean by the radially condition? Radially means that from this point to 5 cm to 10 cm, if we draw a circle, if we draw a sphere, then electric field line's strength is always same in the radius wise direction or in the spherical direction. This is the concept of spherical called the radius or radially outward. And in the same manner, the electric field lines for a negative charge is radially perpendicularly inward. Radially, the concept same, that at 5 cm, at 10 cm, the electric field line's strength is same. Electric field lines for positive and negative charge start from positive, continuous curve with smooth lines and ends at negative. Negative comes perpendicularly inward, positive radially outward. If both the charge are of same nature, positive, there must be some repulsion between them. Positive strength repel each other. They do not meet with each other. So repulsion shows the weak electric field lines. So in the positive negative, electric field line strength is greater, and in same nature, electric field line strength is lesser. And here some point is there in between at which the strength of electric field lines is 0. So electric field lines exert a lateral pressure on each other, repulsion having neutral point where the net electric field is 0. So these are the concept of electric field lines. So in the next video, we will discuss the next topic, properties of electric field lines, and thank you.